Exercise 110. Let's continue to talk about the kernel of theta. So first exercise. Let's call it proposition. So let's first recall that we have proved, let's say, proposition 0. Kernel theta is principal. Is the principal ideal generated by C. We'll recall this C is omega 1, 0, 0 as element of WR. This omega bar is as element of R starting with minus P. So exercise 1, intersection for power of the ideal is 0. In some sense, this is separated for the kernel theta topology. Proof. So take any element in the intersection of kernel theta. Then notice here it's W of R. If I modulo P, I could got here, and here I have evaluation. This is mod P, so where R of X bar is then bigger equal than we are of X bar to the power n for any n. Should write this X bar. Recall that so we of X bar, this is just because we already have description C as element of WR, so modulo P basically is just left with omega bar, so this is we R of omega bar as element of R, and so this definition is given to be the OCP or OCK valuation over the first component of it. By definition, this is with CK of minus P, which is 1. And why here we have this bigger equal? Because X is C to the power n, xn prime. So for any integer, and this xn prime W of R. Right, and then we modulo P, this gives you X bar equals C bar times X prime bar. This is in R, so in particular its valuation is bigger or equal than 0. And So at least they have this. Let's continue. So this is obviously already telling you that x bar equals 0 because it's bigger or equal than its valuation for n, so its valuation is infinity. Good, which means that x equals p times let's see, y wr, right? But then notice theta of x is p times theta y, and then in wr this is p torsion free, and then theta of x, so this is 0, implies that theta y is 0, implies y is in kernel of, intersection of theta to the power n for any n. And then, as you could imagine, just by iteration, this was telling you that, so p d with y, and then just continue, it tells you that x is divisible by whatever p power, so x is 0. Induction or iteration. Let's say second exercise. An element, let's say R0, R1, kernel of theta containing WR is a generator of kernel theta. In other words, if and only if R1 is a unit, is a unit in the ring R. So it's proof to some precise computation, some things. So let's write the general form of kernel theta element of kernel theta as, because we know it's principal generated by xc, so let's write it as xc times some element. Let's say x0 is 1. So let's say xc is in wr, and then this is in wr. Moreover, we know what is xc. Xc is as we described. This one, the multiplication with 0. And then we have precise polynomials at each position to describe the multiplication. So we only need the first few ones actually. So omega bar is 0. This is the first one. Well, the second one will be omega bar to the power p times s0. Sorry, s1 plus s0 to the power p times 1. And so we have very precise description of this one. If we call this R, I'm writing a general element of kernel. Then its R1 is in general form like this, plus and then we notice that this has its valuation bigger or equal than p times the valuation of omega bar. Everything is in R, so let me think. Yeah, And so this is P, right? And so R1 is in unit by definition if and only if we are R1 equals 0, then if and only if. So this is already positive valuation if you have addition with another one, its valuation would be bigger or equal than the minimal one. And if it's different with the minimal one, this is equivalent to we are 0 to the power p equals 0, and this is if and only if S0 is a unit of R. And this is further equivalent to telling you that that element itself is a unit of WR. And this is telling you that R and this element, let me call it R, R is different by a unit with C, and so this is our kernel theta. And so we are done. That's exercise 3. So is the derivative of epsilon minus 1 a generator of kernel theta? So let's discuss this. So we have to find the R1 of this, right? So firstly, as an element of R, this is recall 1 ZP, ZP square, etc. And the Teshima lift of this is this 0 elsewhere, and 1 is as an element of root ring, like this. I think this should be this, so correct me if I made a mistake. Reasonably, when you do multiplication, you have to make sure every is this reasonable? Is this reasonable? Just change the sign. I'm not sure actually. Yeah, because if you do this, actually you're telling that each component multiplied by this element compared with multiplied by 1 is changing sign, but the addition inverse of an element is not changing sign for each component. Yes, I doubt this. Yeah, I have a doubt on this. I have a doubt of this. I'm not quite sure about it. Maybe let's check it. I mean, when I say check it, I'm only going to check the first few terms of it, of course. for example, if you check this plus this, let me just look at the first few terms. So the first one, this is trivially 0. The second term, it should be, so let me write down. So we have S1 x0 x1 y0 1 given by x1 plus y1 minus, so no matter this is a characteristic of P or not, don't be confused by this 1 over P. It makes sense because say Pi is always divisible by P and you can cancel it. It never really exist. So this polynomial makes sense. And show you this case. This would be actually let me just take an example. P equals 3, then this is, this term should be firstly 0 plus 0, and the minus, first say 3, so say 1 over 3 times say 3, 1 minus 1 square plus 1 over 3 times say 3, 2, 1 square minus 1, and that's all it, what it is. Compute, this gives you 1, this gives you minus 1, so it's still 0. I'm kind of going to believe this is the correct one, so if I made a mistake, so remind me, I will check it. So suppose this is indeed the case. So anyway, I mean, maybe I made a mistake here, but the idea of compute run is just using this correct formula, so we're going to check it. So of course we have to first check this is in the kernel of theta, because theta of this is just, theta is a ring map, so it's just theta of this minus 1, and everything fall into OK bar OCK, let's see, OCK. And what is this, right? So this is by our formula epsilon 0, right? Minus 1 because all the epsilon 1 are 0. This is just epsilon 0. And so this is just 1 minus 1 equals 0. Okay, now let's look at the R1 of it. So this is, I would say, epsilon 0 and then minus plus minus 1. Let's use this. Let's see what happened. If we use this, then the first term is this. Anyway, we don't care. We want to compute the second term, right? So again, let's use that formula. Let me just take an example of 3. I mean, it should be the same thing, but I don't want to be trapped there of the combinatoric formulas. So in that case, this would be, again, as what we said, minus 1 over 3 times epsilon square minus 1 plus 1 over 3 times epsilon times minus 1 square. This should be the second term. So let's summarize this. Simplify it. This is minus epsilon square plus epsilon. This is epsilon square minus epsilon, which is epsilon times epsilon minus. So we care about the valuation of this is positive or not. So this is this. Right, and we know this is just way of epsilon 0, which is way of 1. Plus. I mean, this is just 0. So what is left is only this one. What is this way epsilon minus 1? Again, this is just way of, it's just a way of first component of this. As we say, this is epsilon minus 1. Actually, we have computed what it is in the previous exercise. This is actually p p over p minus 1. And so this is positive. And so this is telling that this element is not in the unit of R, and so epsilon is not a generator. Of kernel theta. Do I have to discuss P is 2 or not? I didn't say where I need to do that. Let me first be safe to say when P equals 2. P is bigger than 2. What happened if P equals 2? What happened when P equals 2? Did I use something about characteristic doesn't equals 2 and simplifying this term? Let me see. So -1 is the same as +1. Okay. Yeah, when EP equals 2, actually the whole formula just changed, right? Then this addition term, p equals 2, it turns out to be, so here is still epsilon -1. The second term would be well, it's the same also as 1, so 0 plus 0, and then p equals 2, then I from 1 to 1, so there is only one term here, which is 1 over 2 minus 1 over 2 times c21 times x01 times 1. Yeah, so the whole formula change. And here this is just minus epsilon or epsilon, and we know that this is 0, right? So when p equals 2, this is indeed a unit, and so is a generator of kernel theta. Good, interesting. So let me put the final remark. Firstly, we recall that K0 equals frac of doubling K. It's maximum ramified between QP and K. Let WR invert P to be WR invert P. WR is still p-adic, discrete valuation with uniformizer P, so just invert P. And therefore we could extend the scatter one. Notice that this is a fact. So when you adding all the finite power denominator is the same as saying I'm union all the finite power denominator, right? And so this could be seen as direct limit of, right, with the transition, just the inclusion for all those universe. Then notice the homomorphism theta. Surjective until it extends to, let's call it theta Q inverting P. And when I show this is again surjective, continuous, GK equivariant. And the continuity of this extended map is obvious. So for any x in ck suffices to check the continuity at any p times n times x. I mean, just at some exercise suffices to check the continuity at some. Could choose whatever, but you could find one such that is 4 into OCK, right? And then you just check it there. And then just use the continuity of the previous theta. The kernel of this theta q is the principal ideal being generated by C.